The vast majority of chemical reactions actually happen in solutions. Solutions are all around us, from the apple juice in our fridge, the fillings in our teeth, from the plasma in our blood into the air we breathe. Hence, solutions are abundant in our daily lives and are an essential topic in chemistry. Solutions do not have to be liquids, aqueous, or water-based. They are essential to life and are widely used in organic chemistry. Many physical properties of solutions are determined only by the concentration or amount of solute in the solution, not by the solute's identity. The concentration in these can be expressed as a mole fraction, molarity, or molality. These are known as colligative properties. What are colligative properties? Colligative properties are properties of a solution that are not dependent on the chemical nature of the solution's components, but are rather dependent on the ratio between the total number of solute particles to the total number of solvent particles. The four colligative properties that can be exhibited by a solution are boiling point elevation, freezing point depression, vapor pressure reduction, and osmotic pressure. Before we start our discussion, here's our objectives. First, in this topic, we will review the osmotic pressure colligative property of a solution. Second is to describe the osmotic pressure through an experiment to elaborate the topic.
Do you ever wonder why we get told to gargle salty lukewarm water whenever we have a sore throat? This instance is a good example to describe osmotic pressure. This is because sore throat is caused by the swelling of cells and tissues surrounding the throat. Due to excess water, the salt water we use for gargles has a lower water concentration than the cells of the throat. As a result, water molecules move from the swollen throat cells to the salt water, reducing pain and inflammation. What is osmotic pressure? To define osmotic pressure, it is the measurement of the tendency of water to osmotically enter one solution from another. It is also called the amount of pressure required to stop fluid to flow on the solution of a side of semi-permeable membrane while being separated from pure water. To further explain osmotic pressure, we have conducted a simple experiment.
Step 1. To start off with the experiment, first, let's prepare the following materials: water, 3 plastic cups, potato, sugar, salt, ruler, and plate. Step 2. Peel the potato, then cut 6 equal-sized potato strips. Record the characteristics of the potato strips. Step 3. Put water in the plastic cups. After putting water in each plastic cup, put 1 tablespoon of salt in the first plastic cup. Put 1 tablespoon of sugar on the second cup, and leave the last cup with only water. Label the plastic cups according to the respective substances mixed or added. Next, step 4. Put 2 potato strips in each plastic cup and wait for 30 minutes. After that, step 5. After 30 minutes, arrange the potato strips on a plate according to their respective labels. Lastly, step 6. Observe and record the changes in the characteristics of the potato strips.
As for the results of the experiment, the potato and the salt solution, which are 4.3 cm in length before and has the characteristics of being firm and hard, shrunk to 3.9 cm in size after being submerged in the solution for half an hour. It also became softer than before since it can be bent easily and led to gaining a dark and yellowish appearance. For the potato submerged in the water and sugar solution, which are 4.3 cm in length before and had the characteristics of being firm and hard as well, they shrunk to 4.1 cm in length and looked yellowish in color. The potatoes became a bit soft since they can be bent a little now. And for the potato and the water, no changes occurred with the potatoes. In its intricate and firm characteristics, a natural yellow color remained.
Here is the explanation for our experiment. Osmotic pressure was applied in this experiment because the level of sugar solution that was poured inside the potato arises after some time. This is due to the entry of water that was poured outside and around the potato through the selective permeable membrane of the cells.
With the collected results from the pre-test and post-test conditions of the physical characteristics of potato peels, we conclude that the clear concept that surrounds the change of potato peels is osmosis. It is the movement of water molecules from high concentration to an area of lower concentration through a selective permeable membrane, such as the cell membrane of the potato cells. The direction and rate of osmosis would depend on the concentration of the solution, specifically the salt and sugar solution used in the experiment, and the osmotic pressure gradient established between two sides of the membrane.